Hello everyone and welcome to another video. If you're watching my videos on brain health and Alzheimer's, you know how much I care about what we put in our bodies. Today, we're diving into a family review paper written by Dr. Arvind Kumar Chaudhry and Mr. Roberto Cucurello. Dr. Chaudhry's paper is titled Artificial Sweeteners on Brain Health, Neurovascular Changes and Cognitive Decline in Indian Population. This was published in 2025. And the journal is the European Society of Medicine. And then we have another paper written by Roberto Cucurello. This is titled Disrupting the Gut-Brain Axis, How Artificial Sweeteners Rewire Microbiota and Reward Pathways. This was also published in 2025 in the journal International Journal of Molecular Sciences. So just to preface Dr. Chaudhry's paper, India has a massive diabetes and obesity rate. Artificial sweeteners like aspartame, sucralose, and saccharin are everywhere in diet sodas, sugars, sugar-free snacks, and even traditional sweets. They promise fewer calories and better blood sugar control. But what are they going to do to our brains long term? We're going to break it down in this video. Okay, so I want to title it Why Sweetness is Not Always Good and How Artificial Sweeteners Affect the Brain. So the first thing we're going to talk about today is the gut-brain axis. A recent review, the one that I showed you earlier with Roberto Coccarello, highlights how artificial sweeteners may rewire our gut microbiome and brain's reward system, potentially undermining the very weight control goals they promise by disrupting satiety and true satisfaction from food. What does that mean? So, sweeteners tend to be 2 or 10 times more sweeter than sugar, and usually the body will interpret that as a higher energy delivery system or higher energy delivery route. So it will interpret that as releasing more insulin. If insulin is in the system and there's no glucose to be put into the cell, this can lead to insulin sensitivity over time if you're constantly using the sweeteners to activate insulin. Insulin sensitivity or insulin insensitivity may lead to type 2 diabetes. The whole idea of how this delivery system can attenuate the reward signal is that if your brain assumes that the high amount of sugar you're intaking is paired with high energy delivery foods, it will change the circuitry within the dopaminergic system so much so that like it's going to be, for example, okay, so if you if you overstimulate the dopaminergic system by getting something that is highly dopaminergic like a drug like cocaine, for example, that system becomes overwhelmed and exhausts itself, right? So when you, for example, are taking these extremely sweet foods, and then you go and you have something like an apple afterwards, it's not going to be as rewarding as if you were to have something like highly processed ham, for example, something that's been processed to kind of activate these systems. So what I'm trying to get at is this reward system will attenuate the reward system so much so that the body will kind of will only offer the rewards whenever the person is eating foods that are extremely stimulating. So these tend to be highly palatable foods that are usually in most times they tend to be very highly processed, and those are not good foods. Those are foods that lead to type 2 diabetes. Those are foods that lead to problems down the line. Another thing that these sweeteners do are affect the type of bacteria that exists. One study, the study that was written by Roberto Coccarello found that there was when it was reviewing some of the studies, they found a study where the bacterium that is influenced within when you eat a lot of sweeteners, the bacterium that starts to dominate is the type that produces GABA. And what GABA does is it inhibits satiety signals. If it inhibits satiety signals, it's going to be harder for the person to stop eating when they're supposed to stop eating. This can lead to obesity, and it can also lead to diabetes as well. So this becomes kind of a feeding loop in itself, whereby you have you've affected your reward system in such a way that attenuates it so that it only wants highly processed foods. And then you also affect your gut microbiome by making it produce a specific type of bacterium that will only produce a neurotransmitter that is known to reduce satiety signals. So if you have reduced satiety signals and the coupling of a reward system that's catered towards highly processed food, you're going to be eating highly processed foods and not stopping to eat those highly processed foods, leading to a chain that will eventually lead to type 2 diabetes or any type of obesity. So it's important to take this into account when we're talking about using sweeteners. Now, there haven't been any studies specifically linking the sweeteners to a specific brain disease down the line, but the fact that the sweeteners are already doing this in a short-term level can kind of dictate how this may influence somebody who, for example, already has a chronic disease and how bad that chronic disease will be exacerbated if they started to input insulin, or sorry, not insulin, sweeteners within their diet. So we're gonna break that down a little bit more. So let's go back to Dr. Chaudhry's studies. So in India, there is a rise in artificial sweeteners. In recent years, the sweeteners in India have exploded in popularity, especially in urban areas, with over 77 million people living with diabetes. Many turn to them for weight management and glycemic control. Short term, they can help reduce caloric intake and support blood sugar management, but Dr. Chaudhry's review highlights a growing concern. While they seem safe for immediate use, emerging evidence suggests potential risks for neurovascular health and cognitive function over time, especially relevant for our population with high metabolic disease rates. So, how do they affect the brain? So, here's what the science shows based on the paper that was written by Dr. Chaudhry. Oxidative stress and neuroinflammation. Sweeteners like aspartame and sucralose are linked to increased oxidative stress and inflammation in the brain. This can damage neurons and accelerate cognitive decline. Blood-brain barrier disruption. They may compromise the protective barrier around the brain, allowing harmful substances in the disrupting and disrupting normal function. They can lead to changes in the cerebral blood flow, which means its altered blood supply to the brain can impair nutrient oxygen delivery, raising risk for vascular issues and neurodegeneration. Also can attenuate gut-brain axis disruption, which I just explained earlier. So sweeteners can mess with our gut microbiome dysbiosis, reducing beneficial bacteria and short-chain fatty acids. Short-chain fatty acids are important in regulating the gut barrier so that nothing leaks into the lumen of the gut, which can eventually get into the blood. So reduce beneficial bacteria and short-chain fatty acids that support brain health. This bottom-up effect worsens neuroinflammation and cognitive problems. If the gut barrier is infiltrated, there's going to be inflammation. Inflammation leads to immune system activation, leads to further inflammation. If you're dealing with the cycle that I was talking about earlier, the really destructive cycle, if you have that chain already going, you're going to have inflammation and oxidative stress already um, coupled to that. Because if the body is kind of eating and not stopping to eat, and the kind of food that it's eating is very um, processed. Usually, processed foods tend to cause the release of um, they they tend to release harmful metabolites. Those metabolites tend to increase inflammation, and inflammation tends to lead to, if not controlled, can be chronic, and the chronic inflammation can lead to diseases that can sometimes be uh, causative to neurodegenerative disease such as Alzheimer's disease down the path. That's if it's not controlled, if the inflammation is not controlled. So it's important to have that part of the body in tight control, basically. So for people with type 2 diabetes or obesity already at high risk, these effects may be amplified, potentially increasing vulnerability to cognitive impairment and disease like Alzheimer's. So Dr. Chaudhry references multiple studies, including Indian data showing limited short term benefits for weight and glycemia, but higher insulin resistance in some users, low public awareness of potential risks among diabetics, widespread monthly use around 30% in urban areas. While not every study agrees, the review stresses that long term excessive use could contribute to neurodegeneration risks through these pathways. Natural alternatives like stevia are a more positive nod in some contexts, but overall caution is advised based on this paper. So, just to summarize, while artificial sweeteners offer short term metabolic perks, this review urges us to think about twice about long term brain health impacts, especially in India, where metabolic and neurodegenerative conditions are on the rise. More targeted research is, of course, needed, but the tips that can be given from this paper are you have to be using them sparingly, prioritize whole foods over natural options all the time, stay hydrated, exercise, and support your gut health as much as possible. Consult your doctor, of course, and especially if you have diabetes. So, what do you think? Can you cut back on artificial sweeteners? Drop your thoughts below. If this helped, like, subscribe, and hit the bell for more neuroscience explained simply. Check the description for a full paper link, which I will put it up. And please, thank you so much for watching. Stay curious and protect that brain. See you next time.